hope you are fine right now. Again, we are in physics about matter, three states of matter. Before starting the state of matter, what is the matter? What is a matter? A matter is anything that has mass and volume, and of course it occupies space. Is anything that occupies space and have mass and volume. This is what you call a matter. That is why we have three states of matter. Number one, there are three states of a matter. A matter can be in solid state. Number one is solid. Number two is liquid. Number three is gas. Let us see some properties, characteristics of substance in solid, in liquid, and of course gas. What you have to know is this. Solid are hard and strong. Why solid are strong and hard? Solids are hard because their particles or the particles that made them are closely packed together. That is why solid are hard. You understand, my student? Thank you. Solid are hard because their particles, the particles that made solid, are closely packed together. Closely packed together. They are packed together. That is why solid are hard. For gas, particles in the gas are far apart. It means they are not closely together as in solid. That is why gas are somehow soft. For liquid, particles are moderate packed together. The main is they are not closely packed together as in solid, but in the gas they are far apart. Far apart, what does it mean, my student? It means the distance between one particles and another is very large. One particle is here, another is here, another is there. Diagrammatically, by using the diagram, diagram, solid particles are closely packed together. It is shown by like this. This is solid. It means the distance between one particle and another is small. That is why solid is very hard. But gas, one particle is here, another is here, another is there. It means the distance between one particle and another is very large. That is why it is easy to compress, to reduce the size of gas. For example, you have a balloon. It is easy to compress because the particles in that balloon, they are far apart. For liquid, particles are not closed like a solid, are not separated like in the gas. They are moderate, packed together. They are moderate. They are not closed and they are not far. They are moderate between. Question is this: why is it easier to compress gas than solid? The answer is there. It is easier to compress the gas than the solid because solid are very hard and strong. Because the particles are closed together. If the particles are closed together, it is not easy to reduce the size of that solid. But for gas, particles are far apart. Particles are separated. If the particles are separated, it is easy to reduce the size of that substance. That is why it is easy to compress. To compress means to reduce the size. The opposite of compress, it is expansion, increasing the size, expansion, reducing the size, compression. That is why it is easy to compress the gas. It is because the particles in a gas are far apart. The distance between the particles in a gas, they are very large. Thank you so much, my dear student. Hello, class. How are you? Hello. Okay, very nice. We are here again. Physics. Kinetic energy. Kinetic energy, it is energy due to the motion. What does it mean? When a body is moving, the energy that body is processing, those energy is called kinetic energy. That is why kinetic energy is equal to 1/2 mv squared. This v is velocity of a moving body. That is why kinetic energy is related to the motion of a body. This is velocity. What is velocity? It is a change of displacement in a given time. And the m is mass of the body. That is why, of course, when a body is moving, it has a mass. energy, it's about moving of a body. It is energy due to motion. By definition, kinetic energy is energy due to motion. Brother of kinetic energy is called the potential energy. On the other side, on the other hand, there is a potential energy. It is written in as breathing. When the body is moving, it is kinetic. You understand? Thank you. But when the body is in any position, when the body is located in any position, we call it potential energy in the hypothalamus. By formula, potential energy is equal to mass times gravity times H. This H symbolizes position of a body. Body is moving, kinetic. Body is not moving, it is at any position. We call potential energy. By definition, where M means mass and G means acceleration due to gravity, and H, which is symbolizing height. Which show the position of a body. By definition, potential energy is defined as the energy due to position. Do you understand me, my student? Wow, thank you. Those are the differences between the potential energy and the kinetic energy. Again, potential energy is energy due to the motion. When the body is just moving, we call it kinetic energy. But when the body is located at any position, we call it the potential energy. Let us see some exercise, practicals about this kinetic and potential energy. After studying some difference between the kinetic energy and the potential energy, let us do some practical examples through exercises. A rock of mass of spectrogram is thrown vertically upward with an initial velocity of 10 meters per second. Calculate its initial kinetic energy. Calculate the kinetic energy of the rock when it has moved up to distance of 3 m. We have mass, which is equal to 3 kg, and we have velocity, which is equal to 10 meters per second. This is number 8. We know that kinetic energy is equal to 1/2 meter and not meter mass times velocity square, which is equal to 1/2 times 3, because the mass is supposed to be kilogram, times 10 square, which is equal to 1.5 times 100. which is equal to Joule. This is number A. Number B, calculate the kinetic energy of rock when it has moved up distance of 3m. This is not the kinetic energy, it is the potential energy. It is energy when it is moved at 3 meters. Because we have position, a height, distance, it means the potential energy. There is an error, but no problem. Potential energy is equal to mass times height times gravity times height, which is equal to 3 times 10, which is the gravity times 3, which is equal to 90 joule. Thank you so much. God bless.